Okay, so this is known as Autodesk Inventor. This is a CAD program that we use here in Engineering Design 3, if you take with me. And it's loading up still at the moment. But ultimately, as any 3D print that you want to make, the first step that you have to do is you have to draw the object. Okay, once you get the object drawn, then you can turn around and turn it into what's called an STL file. It's a .stl, and what's an STL file? It's something that the 3D printer would read, a file that a 3D printer would read. So once we turn it into that file, then we could take it and put it into the 3D printer or send it to the 3D printer. And we use what's called a slicing program to kind of tell, when we're turning it into the STL file, we tell it how fast the printer can, how fast to heat up, what to heat up to, how fast to run, and we can give it a lot of variables to try it, which will ultimately change the time it takes for that print to take. Sometimes we could say, oh, I want this print. We could do it in a couple hours, or sometimes we can make it take the whole day. If we slow it down, usually a lot of times, if you look really closely at something that was 3D printed, and I don't know if you'll see it, but there's like little lines in it. And sometimes when we slow it down, you can't see those lines as well. But that makes it take more time. Sometimes when you slow it down, it'll stick to the bed of the printer longer, which is another thing. That's ultimately what we want it to do, is we want the plastic to stick to the bed, and sometimes it doesn't, and it balls up. If that's not happening, we have to slow down the speed a little bit. So these are all variables that we can change in what's called a slicing program. But again, the first thing that we have to do is we have to come in here and draw it. So if I wanted to draw an object, hopefully you guys get to edit this, right?
Yeah.
Good. And I can say nice things while we're young. Okay. So I'm going to go in here, and these are our three little planes. These are three planes. So you got what you've known in life is your XY axis.
Mm-hmm.
Okay, and then we also have what's called Z axis that goes along it. So we have our XY plane, our YZ plane, all right, and our XZ plane. All right, so here's my XY, and if I click that right there, you can see it's here. And this is just like our X and our Y axis. And I come in here and I can go draw an object. All right, so I drew myself an object right there, and it looks like a really simple little object.
Mm-hmm.
And this is like a little L right there, okay? But if I go in here, and once we've made a flat two-dimensional drawing sketch of it, then I can go in here and I can extrude it, or I'm going to revolve this one. And extrude just means we're pulling it out and giving it that depth, okay? But I'm going to do a revolve here, and I'm going to pick this object right here that I made right here. It revolves it around, and I'll hit OK. And you see that it revolved it, and when I go up here and look at it, you can see it made a little hole in there, and it's got that little ledge down in there too.
Yeah.
Right, so that's just like kind of making a part right there. Mm-hmm. This is a revolved one. So that's it right there. And then once I made this part, I could take that right over there then, and then ultimately turn this into an STL file. Once I get into an STL file, then I'm going to take it and put it in my slicing program. Okay, so if I go in here to one of those, this is my slicing program for our computers here. I'll open up, and the slicing program is basically, again, tell it, we can put some of the variables in. We can load the part in here. Pumpkin teeth. Okay, there it is. I printed this for 1 October for Halloween. I took a pumpkin and it was just a bunch of teeth you shove in. So these are all the teeth for the pumpkin. Okay, and you can put it in. So once we get it in there, then we go in and we can tell certain things. And as I get in here, we can start telling how thick the layer of plastic that comes out. If we want it to be really thin, really thick, and ultimately, again, that's kind of like if we make it really thin, the layers, then you won't see the layers. If you make it really thick, you could probably possibly come up to the part, and you're probably not going to see it on camera, but you could almost see the layers that were on there. Okay, so that's part of it. We come in here and we tell it the temperature of the extruders, how hot we want them to be. We tell them how fast we want the speed of it, the nozzle to be going as it's putting it out. The slower we go, then the better chance of it sticking and the better chance of it looking nice and neat. If we go really fast, it'll be done quicker, but we run the risk of maybe it not printing correctly. And then as you go in here, you can tell other things. So sometimes you can tell things like supports. So basically it's building it layer by layer by layer. When it got up to here and had to go across here and build this layer here, well, there's nothing there to support it. So it could, if it was too far, it could fall down. So you have to build little supports in there to make sure it's held up. And ultimately, in the end, we can go back and tear those supports out. And I have an example of that. If you let me get this here, I'll show you my examples here in a second.